Hi everyone, this video about networking problem solutions in computer networks. Our first problem is it is desire to send a sequence of computer screen images over an optical fiber. This screen is 3840 pixels by 2160 pixels, each pixels being 24 bits. There are 60 screen images per second. Now what's the data rate is needed? The pixels per frame is 3100 380 by 2160 pixels. This is the pixels per frame. Now bits per frame. The bits per frame. Next is bits per second. Therefore, the total rate is 1194 gigabits per second. Now our second problem. Television channels are 6 megahertz wide. How many bits per second can send if four levels digital signals are used? Our solution. This is our solution, and these four for four level digital signals are used. So the our answer is 2 into 6 into 10 power of 6 into 2. So 24 into 10 power of 6 bits per second. Final answer is 24 megabits per second. Third question, if a binary signal is sent over a 3 gigahertz channels whose signal to noise ratio is 20 dB, what is the maximum achievable data rate? And this is our process. This is based on Shannon capacity formulas. C is equal to B into log power of 2 into 1 plus 2nr. Here we taken as bandwidth 3000 and Hz is 3 kHz. Signal to noise is 20 dB. Now in the first step we convert the SNR from dB to ratio. In the second step we are applying an Shannon's formula. Now the approximate values is now we are calculated a capacity of this. So we get that 19,980 bits per second. Fourth one, 10 signals, each requiring 4000 Hz are multiplexed onto a single channel using FDB. What is the minimum bandwidth required for the multiplexed channel? Assume that God bands are 400 wide. Our solution is here we taken bandwidth 10 signals. So 10 into 4000 Hz. We get 40,000. Number of guard bands are needed. 10 minus 1 is 9. Now the total guard bands are is 9 into 4000 into Hz. We get 3600 Hz. Therefore the minimum total bandwidth is equal to single bandwidth plus guard bands. We got the 43,600 or 43.6 kHz. Now fifth one, why has the PCM sampling time been set at 125 megaseconds? To reconstruct a signal perfectly, it must be sampled at least twice its highest frequency. In telephony or a voice systems, the voice channel is limited to 4 kHz. Speech in filtered 300 to 3400 Hz. So minimum sampling rate is required. So Fs is equals to 2 into 4000 means 8 1000 samples per second. Sampling interval is reciprocal of sampling rate. So the TS is equal to 1 by 8000 seconds. Answer is this is the answer. Now sixth one. What signal to noise ratio is needed to put a T1 carrier on the 1 megahertz line? The answer A. T1 carrier has a data rate is C is equal to 1.544 Mbps. So the available channel bandwidth is 1 lakh Hz. We need the find in the required SNR. So log 2 into 1 plus SNR is equal to C by B. We get the answer 1.92. This is in linear ratio. Now convert to dB. We will get 2.83 dB. This is our needed to put a T1 carrier on the 1 Mbps line. Now seventh one. A cable TV system has 100 commercial channels, all of them alternating problems with advertising. Is there more like TDM or like a FDM? Here TDM is time division multiplexing, FDM is frequency division multiplexing. The TDM would mean each channel takes turns using same frequency band in the different time slots, which is not how TV broadcast works. A cable TV systems with 100 channels is like a FDM, not TDM. Now, eighth one. A cable company devises to provide internet access over a cable in a neighborhood consisting of 5,000 houses. The company uses a coaxial cables and the spectrum allocation allowing 100 megabits per second downstream bandwidth per cable to attract customers. The company devises to graduate at the 2 Mbps downstream bandwidth to each house at the any time. Describe what cable company needs to provide the this generate. Now each house need 2 megabits per second is guaranteed. Then 5,000 houses into 2 megabits we will get 10,000 megabits. One cable segment will give only the 100 megabits per second. So 100 megabits can serve at most 100 by 2 is 50 houses. So to serve 5,000 houses, the company need 5,000 by 50 is equal to 100 separate cable segments. Therefore, the cable company must split the network to that each coaxial segment serves no more than 50 houses, which means 100 segments in total.